Video, we're going to be describing some trigonometric ratios. So to get started, there are three main types of trig functions. They're called sine, cosine, and tangent. Each of these trig functions, when evaluated, is going to be a ratio comparing two sides in a right triangle. Which two sides, you might be asking? Well, each trig function is going to want to compare two different sides in our right triangle. For example, the sine ratio is going to want to compare opposite to hypotenuse. Cosine is going to want to compare the adjacent side to the hypotenuse side. And the tangent function wants to compare the opposite side to the adjacent side. So notice that sine and cosine involve the hypotenuse, while tangent does not. There's an acronym to help us remember which goes with which. So, ka, toa is something we can say over and over to remind ourselves. Notice that so, S stands for sine, O stands for opposite, H stands for hypotenuse. In the ca section here, C stands for cosine, A for adjacent, and H for hypotenuse. And in our tangent or toa section, T for tangent, O for opposite, A for adjacent. So knowing this acronym will remind you what pieces go with which trig function. Here's the slightly tricky part. It totally depends on what angle is involved in the problem. For example, if angle A is my angle of reference, then everything is based on or relative to that position. So the side that is across from that angle is going to be labeled the opposite side. The side that is next to that angle is going to be the adjacent side. And the side that's across from the right angle is always the hypotenuse. Hypotenuse will never change, but if I decide to instead use this angle up here, that's going to flip my opposite and adjacent sides relative to that position instead. So always focus on what angle you are using and label your triangle relative to that position. And if you change your angle, make sure that you relabel your triangle based on a different position. Let's do some practice. Given this triangle, let's evaluate tangent of angle C. Evaluating tangent means we're going to be comparing the opposite side to the adjacent side. So angle C is my angle of reference being asked here. So relative to that position, 7 is opposite and 24 is adjacent. For the sine of angle A, though, now we're changing our angle of reference. Now my opposite side relative to angle A is going to be 24. My hypotenuse isn't going to change. That's always going to be 25 in this case. So the sine ratio is opposite over hypotenuse. Cosine of angle A, staying at angle A here, so no need to relabel our triangle. Adjacent to angle A is going to be the side length 7 here, and hypotenuse is still 25. So cosine is adjacent over hypotenuse. 7 over 25 will be our ratio. So one way that we can say the value of trig functions is in a ratio form, or fraction form here. Another way to do it, though, is to take that fraction and convert it to its decimal equivalent. This is what your calculator does. So 7 divided by 24 will give us this decimal, or approximate decimal. 24 divided by 25 is going to give us this exact decimal. And 7 divided by 25 is going to give us this exact decimal. All right, one more time. Go ahead and pause the video if you want to try this next example on your own. To answer tangent of angle X, we want to set up a ratio comparing the opposite to the adjacent side. That's TOA. So opposite from angle X over here would be the side length of 5. Adjacent to it would be a side length of 12. So 5 over 12 is our ratio. 5 divided by 12 is going to give us this approximate decimal equivalent. Sine of angle y. Now we're changing up our reference angle here, so let's relabel our triangle if we need to, or just think based on this position at angle y. This side is now opposite, this is adjacent, and this is hypotenuse. Sine ratio, that's our SO part of our acronym, reminding us for opposite over hypotenuse. Opposite from angle y is 12, hypotenuse is 13. There it is in ratio or fraction form. 12 divided by 13 will give us this approximate decimal. Lastly, cosine of angle y. So keeping the same angle reference. Adjacent to this angle now, it's going to be 5. Hypotenuse is 13. So ca is our acronym for cosine, reminding us that we need adjacent over hypotenuse. So 5 over 13. There's our fraction or ratio form. 5 divided by 13 gives us this approximate decimal. In our next lesson, what we're going to be doing is we're going to be solving for one of our side lengths. One of these side lengths is going to be missing. So we'll have a variable instead of one of our numbers in our ratio, and we're going to be solving for that. We're going to find that our calculator is going to use our ratio as a decimal form. So we'll see that happening. But before we can do that lesson, we got to make sure and know what two side lengths correspond with each trig function. So make sure that you study SO, CA, TOA, and know which two side lengths correspond with each of these trig functions. And then we'll solve for some unknown measures next lesson.